Okay, this is problem number 4, still on page 8. So we are given a circuit. Vs is not given, the value of Vs is not given. We have 5 ohms, 10 ohms, 5 amperes, and then a dependent current source with 6I as its value. But I is already given in the problem, I equals 5 amperes. And then we are asked to look for the value of Vs. And then we're going to look for the power of each element, power delivered or absorbed by the elements. Okay, let us start. This is still KCL and KVL. We have not learned anything yet except the two principles, which is KCL and KVL. Of course, Ohm's law, which I've learned since you were in high school. Okay, so let us determine the nodes and the loop. So we have one loop, another loop. This is a loop also. So the nodes, this is a node, right? This can be connected as this one. So this one also. So this is one whole node. Okay, let us call that node 1, and let us try to perform KCL on that particular node. So let us assume that the current here is going to the right. Let us call this Ix. So the polarity of 5 ohms should be like this because it's supposed to absorb power. So entering KCL at node 1. So entering current, negative 6I, but I is 5. So 5. And then minus Ix because it's also entering the node. And then plus I. But I is already 5. So let us put 5. And then this current is going away from the node. So this is also 5. Equals 0. So how many currents do we have? 1, 2, 3, and 4. Going towards and from the node. Away from the node. So we can now get the value of Ix here. So 5 plus 5, 10. Ix is negative 20 amperes. That's the value of our Ix. So if we're going to remove the negative, then Ix direction should be to the left. So can we be able to get the value of Vs already? Yes. Because we already have I and then Ix, we can make use of this loop. Let's consider this as loop 1. Perform KVL there. So KVL at loop 1. Let's start with Vs, so positive. So Vs is positive. And then plus, so this is plus 5 times Ix. But what is Ix? Negative 20. We have solved Ix as negative 20. Then plus also. Why plus? Because the direction of I is going down. Plus 10 times I. But what is I? 5. As was stated in the problem. So 0. So Vs now equals, this is 100 and this is 50. So now 50 volts. So we're asked to look for the power absorbed or delivered by each element. So let us check first whether the voltages and the currents are given. We have already gotten the value of Vs, and we have also the current is not known. The current is not known. So let us take this node, and since let's assume that the current is going towards down. Why? Because it's supposed to absorb power. Let us call this IS. I absorb deliver power, I'm sorry. So let us get IS by uh, performing KCL at node 2. So KCL at node 2. So IS is leaving. Then IX is also leaving, plus IX. Then plus 6I. 6I equals 0. But IX is negative 20. And I is 5. Therefore, we can now get the value of IS. IS is 20 minus 30 negative 10 amperes. 6 times 5 negative 30. Yeah, so our direction going down is negative. So this is in reality absorbing power. Why? Because if you're going to correct the direction of IS, it's gonna leave the terminals, negative terminal of VS. Okay, what else? We have IX. The voltage of this is not given yet. So the current is 6I, which is 30, but the voltage is not given. So since they are in parallel, we're going to consider this plus and then minus. It's okay, the polarity and the direction of current. If your answer is negative, then we can correct it by reversing the polarity if it's a voltage and reversing the direction of the current if it's a current. Okay, so voltage of 6I. Voltage of 6I is just the voltage across 5, right? So since it's positive terminal, that's also positive terminal because they're in parallel. Negative terminal, negative terminal. So voltage across 6 times I equals 5 times the current, which is IX. But IX is negative 20. So the answer is negative 100 volts. Okay. So negative 100 volts, if we are going to make it positive, then they should be positive and then negative. So this is delivering. We have the voltage here and the current. So the voltage here. So since this is plus, this is also plus, and if this is minus, this should be minus also. Why? Because they're in parallel. They're supposed to have the same voltages. Okay, so the voltage of 5 ohms, this one, 5 amperes, the voltage of 5 amperes is just the voltage of across the 10 ohm resistor. So what is the voltage across 10 ohms? So 10 times I. But what is I? I is 5. So the answer is 50 volts. Therefore, we already have all the things that we need. Let us now calculate for the power. Power absorbed by the VS. Absorbed, why? Because of the direction of the current. So what is its voltage? VS. VS is 50 volts. And what is its current? IS, 10. So this is negative 500 watts, and this is absorbing. Why is it absorbing? Because the IS, the direction of the IS that we have assumed yielded a negative. So if you're going to correct the direction of the current, remove the past negative, then it's gonna leave the terminal negative terminal of VS. So it's absorbing, passive sign convention. Power across 6I, or power delivered by 6I. So what is the voltage across 6I? Voltage of 6I is 100, and then The current is 6I. 6 times 5. So the answer is 30 times 100, 3,000 watts. And this is delivering. Why delivering? Because the voltage across 6I is 100. This is supposed to be absorbing, plus minus. But if you're going to reverse the polarity because it's a negative, it's gonna deliver. So, power 5 ohms here. So, I squared R. What is the IX, right? So, IX. What is IX? Negative 20. Then you square that times 5. The answer is 400 times 5 is 2,000 watts. And this is absorbing. And then power absorbed by the 10 ohms is I squared R, I. And then I is actually 5, right? Squared times R, 10. The answer is 25 times 10, 250 watts. Of course, still absorbing. And then the last, power 5 amperes. Delivered or absorbed? It is actually absorbed. So power 5 amperes, what is its voltage? Voltage is 50 volts here, this one. And the current is 5 amperes. So 50 times 5 is 250 watts. This is also absorbing. Now, let us check whether our answers are correct by determining whether power delivered equals power absorbed total. So, isa lang, there's only one delivering power, 6I, so that is 3,000. Then we're going to add all of this. 500 plus 2,000, 2,500, 2,750, 3,000. So that means all our answers are correct.